Physical versus chemical. This is our third week of content in our study of matter. First week we studied element, compound, and mixture, classifying them, and then also separating mixtures. And then we looked at density and its applications for matter. And then lastly, this week we're looking at physical and chemical, these two terms, and how they're used, what they mean when describing properties and changes. So we've actually seen them used before when we were separating mixtures. Physical separation would mean that we're just maybe changing the appearance or the form or the shape of the substance. We're not actually changing the substance itself. If our sample is still water or is still aluminum, as long as it's still the same substance, we are dealing with only a physical change or property. Chemical has to do with a reaction that's actually taking place, and it changes into a new substance, maybe changing water into hydrogen and oxygen, changing it completely. And that requires some sort of breaking of bonds or forming of new bonds in order for a chemical change or chemical property to be observed. So our physical changes and properties always are related to no reaction. And instead, it's just looking at appearance, form, shape, maybe the measurement, but that is never actually changing the substance itself. Form is referring to even state of matter, solid, liquid, gas. It's still water, even if it's water vapor or if it's an ice cube. So those would even be considered physical changes in properties because we're not changing the actual substance, we're just changing its form. Chemical, on the other hand, requires or has a reaction that takes place with the change or the property. And when I say reaction, I'm referring to anything that creates a completely different substance than what you had before. And that requires bonds to break and new bonds to form. So our bonds within the chemical. Remember when we talked about particle diagrams where the shapes were touching, that was a bond. So if we're changing the particle itself and breaking apart the shapes, now we've created a new substance which will have new properties. Bonds will either break or form, creating a new substance with new properties. Maybe something starts to smell different or it has a different color. Those are all signs of chemical change telling us, hey, I think there's a new substance that's been formed. That is the biggest thing for us to consider when we're looking for signs of a chemical change, is to ask yourself, is there a new substance with new properties? So when we are looking for these signs, start there. If it's not a new substance, then you can automatically say it's not a chemical change. If you think it might be a new substance, start looking for these signs. Okay, so heat. Anytime that you see heat or fire used, which would be a transfer of energy, is another way to say that, or light produced. Heat or light produced, both of these are forms of energy transfer, which you often see in a chemical change. New properties like a color change, or we said an odor or something like that. Generally, we'll see it in a color change. Or we might produce completely different matter altogether. So we have the potential to form gas out of liquids, which would be the formation of bubbles. That means a gas formed. Or maybe a solid formed from liquids, but it wasn't freezing. It actually created new matter from the atoms while they rearranged, making new bonds on the particle level. And we call this a precipitate. Precipitate. Sounds like precipitation, but no, it does not have to do with water. it means that a solid has formed. It's not rain. Okay, so any of those signs that we're looking for, always go back to ask yourself, is this a new substance? Because sometimes things will bubble, but it's not really a new substance. For example, maybe I blow bubbles in a straw. I see bubbles, but I really have to ask myself, is this a new substance? Just because I see bubbles doesn't mean that I'm making a new substance. It has to be under those conditions where you think something new has formed by breaking or forming bonds. So we can use physical and chemical to describe properties and changes. We're going to distinguish between the two here really quickly. A property is an observed characteristic, so something that you observe about a sample. And there are lots of different properties, but these are just observations, observed characteristics. There are a couple of different types of properties other than physical and chemical. We've got two different variations, intensive and extensive. We've talked about these briefly last week, but an intensive property, remember we called that part of the personality of your matter. So it will always be true no matter what. It's depending only on the identity of your matter. So an intensive property is the personality of your matter, whereas an extensive property will change. Usually it's a measurement, so this depends on the amount. Some examples of properties. Let's just list a few. So these are things that you can observe. So we can observe boiling point, we can observe color, we can observe flammability, right? All these different types of things that you could see and kind of decide whether or not something is flammable or tell me what color it is. These are observations, kind of observation categories are properties. And we can have physical properties or chemical properties. If it requires a reaction to observe it, then it's chemical. So of these three here, flammability is chemical because it requires a reaction. It requires you to test fire on your sample to know if it's flammable or not. To look at the color of an object or a sample, that does not require a reaction. To do that, you can just observe it. Same with boiling point. We talked about earlier, changing state of matter is not chemical, it's just physical, changing from water vapor to liquid water to ice water. They're all still water. So both of these, boiling point and color, would be physical properties because no reaction is required to observe it. A change, on the other hand, is not going to be an observation necessarily, but it is when a sample undergoes a clear before and after change or difference. So undergoes a distinct before and after difference. Sample undergoes a distinct before and after difference. So this might be worded a little bit differently if I say, let's see, water is melted from ice into a puddle. So that is referring to melting point as the property, but it would be a physical change because an actual change occurred in my description. Or I might say paper burns. That would be a chemical change. So when I'm actually saying a before and after difference, that would be a change, not a property. Properties are the observed characteristics, or kind of the categories, if you will, of different things you can observe. and changes are kind of describing the difference between before and after. Law of conservation of mass is important because when we're making changes, we need to keep in mind that atoms cannot be created or destroyed. They can't just pop out of thin air and they can't just disappear. They have to be accounted for from the before all the way to the after. So if we are defining the law of conservation of mass, it states that matter cannot be created or destroyed. And what this means is that matter can only be transferred or rearranged in a change, but it can't just, like I said, appear or disappear out of thin air. All of our atoms have to be accounted for. We're going to look at an example down here, and actually we're going to do a part 2 where we look at these examples to make sure that all of the atoms on the before side are accounted for on the after side. We already have an example here that's telling us it doesn't follow the law of conservation of mass, and we will go through that and finish the particle diagram so that it does. Another piece of information we can get from the law of conservation of mass is that the mass of the reactants, or before, will always equal the mass of the products because it can't just disappear. It's our after. And that will be helpful when we're looking at our math skills on Wednesday, looking at reactants and products, and the mass that was used, it has to be equal to the mass that was produced in the end.